Okay, at this point, we want to determine. So the D part of this question is that it's stating that we should determine the response of the system. The response of the system to the input signal x of n. So now solution. So we want to determine the response of the system. So we should not forget that we already know the impulse response of the system from the A part of the question. So that h of z is still this 1 minus 1 all over 4 root 2 0 is to power minus 1 all over 1 minus 1 all over 2 root 2 0 is to power minus 1 plus 1 over 16 0 is to power minus 2. Now we are given x of n at this point. So x of n is what? 1 all over 4 raised to power n u of n. So what do? So we convert this inputs system, we convert it to the z transform. So that will be x of z is going to be 1 all over 1 minus 1 all over 4. 1 over 4 z raised to power minus 1. We know this. You know this, how to convert this. So, and we know that the response of this system, that is y of z, is of course equal to x of z, h of z. You know, just as we know that h of z is, we know that h of z is equals to y of z all over x of z. So from here, we know that our y of z is equal to this. So which is multiplication. So we just need to multiply the two together. So what is x of z, which is 1 all over 1 minus 1 over 4 z raised to power minus 1. Then multiply by 1 minus 1 all over 4 root 2 z raised to power minus 1 all over 1 minus 1 over 2 root 2 z raised to power minus 1 plus 1 over 16 z raised to power minus 2. Alright. So now that we have this, now. So what we'll do is we are just going to multiply the two together. So, and once we multiply the two together, then we are now going to use partial fraction to solve this problem. So y of z is going to be 1 minus 1 all over 4 root 2 0 to the power minus 1 all over 1 minus 1 all over 4 0 to the power minus 1. Then this is going to be this expression here. You know, I believe we have already determined this one earlier. This particular expression, we determined it in the previous question C part of the question. So 1 all over 4 e raised to power j pi all over 4 0 raised to power minus 1. Also, this one is going to be 1 minus 1 all over 4 e raised to power minus j pi all over 4 0 raised to power minus 1. That is if we want to represent this one, just as we did in the previous question that we did earlier. In this question, this one like this expression. So we can represent this one in this format like this. It's just for us to multiply by z raised to power minus 1. And this is going to be converted to this format. So when we have it in this format, so what we just need to do at this point is to use partial fraction to express everything. So y of z from here will be a all over 1 minus 1 all over 4 z raised to power minus 1 plus b 1 minus 1 minus 4 e raised to power j pi all over 4 z raised to power minus 1. Then c 1 minus 1 all over 4 e raised to power minus j pi over 4 z raised to power minus 1. So this is how we are going to express. So you will just need to determine the value of a, b, and c. And how do we determine a, b, and c? A from here is going to be y of z multiplied by the denominator of a, which is 1 minus 1 all over 4 z raised to power minus 1. Then you substitute what will make this one to be equal to 1, so that 1 minus 1 will be 0. What will make this expression to be 0? So, and that is by doing what? By putting this z to be what? To be equal to 1 all over 4, right? So z to be equal to 1 over 4. Because if z is 1 over 4, so 1 over 1 over 4, is going to be 4 over 1, and that's going to make everything to be 0 at that point. So in other words, whatever expression you have at the denominator of a, you equate it to 0, and the value of z at that point is what you're going to use here. So in other words, whatever coefficient you have here is the coefficient, is what this z will be equal to at this point. So once you substitute that, so what is y of z? Y of z is this entire expression. Now multiplied by this, which is one of the denominators. So if this numerator and the denominator cuts, what are we going to be left with? We are going to be left with this one and this expression. And you know that the expansion of this expression is also equal to this expression here. Is equal to this expression that we have here. So we just need to replace that. Instead of writing this gigantic double bracket expression, we just use this one to replace it. So since that one is more comprehensive, so we just write it as this numerator here, 1 minus 1 all over 4 root 2 0 raised to power minus 1 all over. So we now write 1 minus 1 all over 2 root 2 z raised to power minus 1 is 1 over 16 z raised to power minus 2. So once we have written this like this, we now substitute z to be equal to 1 over 4 in the expression. So if we substitute z is equal to 1 over 4, so how do we go about this? So the first thing we'll do is, so let me show how this is done in the calculator. So the first thing we're going to do at this point is you put 1 minus 1 over 4. So this is going to be 1 all over 4. Then we replace this one by x. We use the z. We use x to represent that. I believe what I've written here is clear. So x, I'm using x in this calculator. I want to use it as a variable in this calculator. I want to use x to represent z in this expression. So anywhere we see z here, we'll be putting x. Then at the denominator is going to be 1 minus 1 all over 2. So that's going to be 1 all over 2 root 2. 2 root 2x. That is 2x root 2, right? So 1 all over 2x root 2. So the other one is plus, this is going to be 1 all over 16, right? 16 x squared, right? X squared. Okay, so now that we have entered the entire expression, so we now want to substitute 1 all over 4. So that's what we want to substitute. So we say press calc. So it's now requesting for the value of x, and that value of x is 1 all over 4 1 divided by 4, right? So we put it there. So, and what is our answer? Our answer is 1 all over 2, right? So we got our answer to be equal to 1 all over 2. So it's as simple as that. Now, when it comes to complex number in partial fraction, normally any complex number in a partial fraction, they are always complex conjugates. So once we get B, it means we have gotten C, because we just need to change the sign at the middle, and that gives us the value of C. So once we do one, we know the second one. So B is the same thing as C conjugates, right? B is the same thing as C conjugates. So it's going to be Y of Z. So for B, this is the expression inside the bracket. This is the expression that it will multiply Z, Y of Z with. So that's 1 all over 1 minus 1 all over 4 e raised to power j pi all over 4 g raised to power minus 1. When Z is equal to whatever is in front of Z inverse here, which is 1 all over 4 e raised to power j pi all over 4. So at this point now, we want to substitute. So when we put this expression now inside this, when this denominator, when it cuts this numerator here, what are we going to be left with? We are going to be left with this numerator, this one, and this one. Those are the three we'll be left with, right? So we have 1 all over 4 root 2 z raised to power minus 1. Then 1 minus 1 all over 4 z raised to power minus 1. Then the middle one is cut off. Then we have this 1 minus 1 all over j to the power minus j pi all over 4 0 to the power minus 1. So at z equals to this expression, when z is equals to, is this z is equals to 1 over 4 e raised to the power j pi over 4. When z is equals to that. So what we want to do now is to put this one in our calculator. Put this expression in our calculator. So if we want to put that in our calculator, we just need to do what? Come here again, make sure our calculator is in the complex form. To put it in complex, just press mode and you press 2. Make sure it is in complex mode. Because that is very, very important. Also, we can decide to make it in degree. To make it in degree, just press shift and mode. We can decide to make it in degree, so that this pi over 4 will become 45. 180 over 4, that is 45. Or if we like, we leave it in radian, we use pi all over 4. So whichever one we decide to use, we still get the same answer. So now what we want to do now, we have set this. Now we don't want to put this in our calculator. So the first thing we'll do at this point is to enter 1 minus 1 all over 4 x root 2. So we are replacing anywhere we see z. This is 1 all over z. So it is at the denominator here. I believe this is understood. We should always make sure it is at the denominator. That's 1 all over z. So here now it's going to be. So we'll put this in a bracket. And there are 2 brackets there, right? So the first bracket, that will be 1 minus. Okay, now we put this one in the bracket. This is going to be 1 all over what? All over 4z, right? So all over 4x, right? So that's clear. Then the second one is going to be 1 minus. Now, how do we write this one now? So we write this one in this format. We see that this expression, what it means is this e raised to power, or this is 1 argument 45, right? This is 1 argument, that is shift this small minus, then this angle is 45. because I've converted it to degrees in degree. Then 4 at the denominator. Then the z is also at the denominator, right? So put the z also at the denominator. Any other thing there? Nothing. So now that we have written this expression like this, we just need to click on calc. And we click on calc, we want to put the value of z, which is this expression here. And what is this expression? Is 0.25 argument 45, right? So 0.25 arguments 45. So that's going to be, so we just need to wait. Okay, there is an error. Where is the error? Okay, it's supposed to be minus 45, not plus 45. That's why we're having there. So it's supposed to be minus 45. So we click on calc again. We have already put this value here. Just click equal to. So this is what we get here. So this is what we get at this point. So the answer is 1 all over 4 minus 1 plus root 2 all over 4j. So if we now convert this particular expression into magnitude and angle, we just need to do what? Shift, then complex number, that's 2, then 3. We select 3. So we have it in magnitude and angle form. This is going to be 0.65. In this format now is 0.65. 0.65 arguments minus 67. Now this, if we want to decide to convert it back to radian, probably we don't want it in this one, want it in radian form, we can say shift mode 4 to convert it back to radian. So the magnitude still is 0.65, but the angle this time around is what? Minus 3 all over 8 pi. So this is going to be the final answer. So we have gotten our B and our C conjugates, our C conjugates. So if we write it like this, or we write like this, is 0.65 e raised to power minus j 3 pi all over 8. So we write it like this. So whether we write like this or it's still the same thing. So we have our B, we have our C. So those are the values that we have gotten. Now after we have gotten this, so we now need to, we have gotten our A, we have gotten our B, and we have gotten our C. So we now put them back into this expression. So let's go and put them in this expression, and we will from there determine what our this one will be. So our A, let's recapitulate this. Our A is 1 all over 2. Our B is 0. Or let's say is 0.65 e raised to power minus j 3 pi all over 8. And our C is 0.65 e raised to power plus j 3 pi all over 8. So these are the values of our A, B, and C. So after we have gotten this, we just need to put them back into YZ. So what is YZ? So our YZ at this point is A all over 1 over, so A is 1 all over 2. 1 minus 1 over 4, Z is power minus 1, plus B 0.65 equals to power minus J 3 pi all over 8 all over what is this? 1 minus 1 all over 4 e raised to power j pi all over 4 z minus 1, right? Then plus C C 0.65 u raised to power plus j 3 pi all over 8 all over 1 minus 1 all over 4 u raised to power j pi all over 4 is j raised to power minus 1. Am I on the track? Okay, this is minus j, right? So now that we have this, we can now convert this back to our time domain. So it is in the z domain right now. So we want to convert it back to the time domain. So to convert this back to so our y of n at this point is going to be 1 all over 2. Then this is going to be 1 all over 4 raised to power n u of n plus, so this is going to be what? 0.65 e raised to power j minus j 3 pi all over 8. So this is going to be 1 all over 4 e raised to power j pi all over 4 raised to power n u of n plus, this is going to be 0.65 e raised to power j 3 pi all over 8 and this is going to be 1 all over 4 e raised to power minus j pi all over 4 raised to power n u of n, right? So this is going to be our final answer. So we just need to simplify this further. But if we stop here, we are done. So we just need to simplify it since we see some things coming out together. So we just need to put them together. All right. So now at this point we have this. So this is going to be 1 all over 2, 1 all over 4 raised to power n u of n. And this having is 0.65. This one's also having is 0.65. You can bring them together. Then also this and this also 1 over 4 is also common. 1 over 4 raised to power n. We can also bring that out. 1 over 4 raised to power n is also common. Bring that out. Then e raised to power this and e raised to power this, so we can bring them out. We can combine them together as well. So it's going to be e raised to power j pi all over 4 n minus this guy 3 pi all over 8. Also, this one also can come together as e raised to power j pi all over 4 n. This is minus. This is having a minus, so we put a minus there. Then when the minus counteracts with this, you have this is going to be minus 3 pi all over 8. Minus times minus will make this one become plus again. 3 pi all over 8. So u of n. I believe this is getting clearer. So at this point, this is our normal cosine. So 2 cosine of this, the one we have been dealing with earlier. So 1 all over this u of n. So plus 0.65 1 all over 4 raised to power n 2 cos pi all over 4 n minus 3 pi all over 8, right? So u of n. So when 2 multiply 0.65, so that's going to be 1.3, right? So 1 over 2, 1 over 4 raised to power n plus 1.3. When 2 multiplies this, that's 1.3. This is also 1 over 4 raised to power n cos pi all over 4n minus 3 pi all over 8 u of n. So this one now, as it is now, you see something is still common. We can still bring 1 all over 4 out. So we have 1 all over 4 raised to power n. We bring them out. So we have half plus 1 all over 3 here, 1.3 rather, then cos pi all over 4n minus 3 pi all over 8 u of n. So this is going to be our final answer. I believe this is clear. I believe this is clear. Oh, we should not forget that, okay, we still have 1 over 2 somewhere around there. So this is our final answer at this point. This is our final answer. So this is the final answer.